Okay, so we have an upcoming mainnet launch in a couple weeks. So I wanted to come up here and talk about what Espresso is doing. Espresso is a network for composable chains. The problem that we address is composability. Composability is the power of Web3. It has always been the power of Web3. What makes Web3 so different from Web2 is that you have systems like Ethereum where applications can be deployed by any developer. You don't need to have, trust relationships between these developers. They don't need to, coordinate, have backroom business deals with each other. All applications can interact with each other. Users can build on top of these applications like money Legos to create new applications that interact with all the existing applications. And that is what makes Ethereum as a product so different from products before. It's enabled by the fact that it's on a decentralized, permissionless system, but from at a product level, what makes it so different is the composability. In fact, what we call this at a more technical level is synchronous composability. The fact that you can have contracts make function calls to other contracts. You can build a smart contract wallet that can automatically trade in a decentralized exchange, but only if it can get the trade executed at a certain price. That's what is enabled by composability. You have things like flash loans, which never existed before. The idea that you could have in a single transaction the ability to, borrow funds, do a bunch of trades, and then return the funds in the same transaction. That is the highest example of how you can leverage synchronous composability. So now, over the last 5 or so years, due to the need to scale, rollups came about. We have a multi-chain world that was born out of this need to scale, and it has brought many advantages. Sharding of computation across different applications. You have diversity of virtual machines, so everyone isn't stuck with the Ethereum virtual machine. You can have other types of virtual machines. Every application can sort of customize its own chain for its own needs. The disadvantages, though, are that this broke the composability of applications across rollups. Right? So if you have your smart contract wallet on one chain, you can't now engage and trade in some decentralized exchange that exists on another chain. Every chain has to essentially replicate its own world of all applications. And this prohibits specialization, right? Chains can't specialize. They can't be the best chain for NFTs, the best chain for gaming, or the best decentralized exchange if every one of them needs to replicate the applications of all other chains. And this is most acute for something like a decentralized exchange where you really want to have liquidity concentrated in one place. You don't want to have liquidity providers splitting their capital between a copy of Uniswap on every single different chain. So Espresso is a solution for chain composability, and it starts with this thing that we call the Espresso network. It's a global confirmation layer. What it does is it confirms the data that clients need to quickly sync a chain state without having to wait for this to be reflected on the layer one, which takes a long time, and without needing to trust centralized parties. And this can be used, as I'll explain in the next few slides, by cross-chain solvers who are bridge providers, shared sequencers, proof aggregators, and different kinds of message coordinators who all facilitate composability in different ways. So in pictures, what it is it's a confirmation layer. It runs a BFT consensus protocol called Hotshot, which scales to thousands of validators. When a rollup integrates this system, it posts its data to this consensus protocol, which confirms the data within a matter of seconds, and that keeps this rollup honest. It makes sure that whatever is eventually reflected on the L1 is consistent with what this rollup posted to this BFT consensus protocol. And so that means that now any other client can look at this BFT consensus protocol and immediately know what happened in the rollup. So let's see how that's useful. Here's how cross-chain intent solvers work. This is the most common way that assets are bridged between rollups today. You have solvers who engage in an off-chain agreement with a user. A user will sign an off-chain request to bridge funds from one independent rollup to another. They'll send a transaction that gets escrowed in a settlement contract, which pays the solver on one chain. The solver then looks at that and it decides, okay, I'm going to now release funds for you on another chain, and I'll take the risk of the settlement message. It's going to take a while for me to get back my funds on the first rollup, but the settlement message will be this long, it take a long time, but it will basically communicate to rollup A that that it released the funds on rollup B, and therefore it can claim the funds on rollup A. The problem is that the solver now takes the risk of posting this transaction B before transaction A is final on rollup A, or it has to wait for a very long time before the transaction on rollup A finalizes on the L1 before it can do so. Now, if you have something like the Espresso network, then the solver's risk is reduced and it can fill the request faster because within a matter of seconds, it has a very trustworthy idea of what is reflected on rollup A before the L1 reflects that information. An even more powerful way of taking advantage of this is now with the advent of synchronous cross-chain messaging protocols, which are being designed in multiple ecosystems, including Polygon, including Optimism, including in ZK Sync. So here, what you have is you have the ability of contracts on different chains to actually receive messages from each other. They have mailbox contracts that implement essentially an outbox and an inbox. And you can do something like a flash loan where you have a transaction on one rollup that's borrowing funds. It's writing a message that it borrowed the funds, and it's immediately reading a message that those funds were received and something was done with them, and funds were minted to bridge back over to the first rollup. You have these two independent transactions on the different chains, and you have a coordinator that's passing messages between the chains in order to communicate with them about what's happening on the other chain. In order to protect the security of this, you have an aggregator that basically creates an aggregated proof about what's happening on the different chains, and if any incorrect message was passed to the different chain, that will be caught by the layer one. But the important thing is that the problem is that when you now have chains now that are dependent on messages which are coming from other chains, the operators of those chains, they don't know their own state. They need to know their own state. These coordinators too, they need to know what's going on these different rollups so that they can pass the correct messages. And that's where, again, this fast Espresso network comes in. A coordinator can, or a rollup operator can read about the state of that chain from the network and immediately know what it is and calculate it and provide the correct messages. We're also going to run a marketplace that will be built on top of this so that chains can easily find these coordinators, cross-chain coordinators, or an example of that would be a shared sequencer who actually can create even more promises around what it might do on the two different chains. In any case, this was a fast presentation. If you wanted to learn more information, we have written a lot of blogs. We have a website. Always feel free to reach out. We have an announcement which is that our main net zero is finally going live this month. We've been running test nets. I think we've run like 6 or 7 test nets over the last couple of years. But we're finally going to a productionized system this month, and we'll have live rollups on Espresso from the Cartesi ecosystem in November and from Arbitrum in January. Thank you.